Hello everybody, my name is John Bivans. I am a student at the University of Nevada, Las Vegas in the Department of Construction Management, and today I will be discussing my research on the critical quality metrics assessment in successful baseline construction scheduling. I'd just like to briefly review my presentation summary and outline. Today I will be discussing an introduction to baseline scheduling within the construction field, an outline of my personal research objectives in this evaluation. I will give a summary of the literary review I've conducted on the topic. I will review my research methodology in this evaluation. I will then discuss my results and the significance of the results. And finally, I will run through a final conclusion of the research and a need for any future work. In today's construction industry, a baseline schedule provides a fundamental basis for tracking project progress, resource allocation, delay impact, cost allocation, and project sequencing. As such, the Association for the Advancement of Cost Engineering defines a baseline schedule as a fixed project schedule that reflects all formally authorized scope and schedule changes against which project performance is measured. Because baseline scheduling is such a critical factor in establishing progress to date and updating progress, projecting out future work, and ensuring a proper finish date, best practices have been established within specific entities in order to ensure a quality baseline schedule. However, no standardized, generic, industry-wide guidelines exist in the creation of a baseline schedule. There exists variation in metrics measurements, required execution practices, and implementation tactics as a schedule is updated and revised. Quality baseline schedules ensure proper project control throughout the entirety of the construction duration. Research objectives for this study include the identification of specific metrics that aid in successful implementation of progress schedules through ensuring the quality of the original baseline schedule. The focus of this research is on baseline scheduling with the assumption that findings can be correlated to any progress update with minimal change throughout the entirety of the construction duration. The research also provides a variety of schedules to be analyzed. In addition, there is a comparison and a contrast of the metrics with impact on three distinct scheduling characteristics, those being the project type, the duration of the project, and the project density, which in this case refers to the number of activities within the baseline schedule and not the weight of the logic within the baseline schedule. Several studies have been conducted within the industry to identify critical schedule metrics that offer insight into the success or failure of a project prior to its onset. However, several of these studies are very narrow in their scope and offer findings with generalized disclaimers as a result. In 2013, an article entitled Project Baseline Scheduling, an Overview of Past Experiences was published by Van Hook in an attempt to gap the bridge between baseline scheduling, schedule risk analysis, and project controls. The issue with this article is that it is based on the author's unique experience and as a result is heavily subjective. Every construction project has unique and specific details that separate it from other construction projects. As a result, one cannot create a generalized consensus based on unique experience. In addition, this research outlines a need for continued metrics research without actually identifying how the research should be conducted. In 2014, an article was published to the AACE International Technical Conference entitled Evaluation of Baseline Schedule Metrics for Successful Project Schedule Performance. In this article, researchers divided 8 commercial and university building projects into 2 groups based on the amount of delay that each of the projects incurred. Schedules were then analyzed based on a list of 27 industry-wide metrics. Although this research proved the importance of several scheduling metrics, it failed to specifically identify critical metrics due to the lack of data and the lack of variety in the selection of both case studies and their corresponding thresholds. Additionally, the results demonstrated that the metrics themselves had a substantial impact on the amount of delay incurred within the schedule, but priority could not be established among those metrics. In 2016, an article was published to the Journal of Professional Issues in Engineering Education and Practice entitled Quality of Baseline Schedules: Lessons from Higher Education Capital Facility Project. This study again established 27 industry-wide scheduling metrics based on standards to be measured against 13 capital facility project baseline schedules. Within this study, researchers were able to identify 5 metrics with the most substantial impact. This study had a bit more variety of analysis based on contract type, project type, referring to new versus renovation projects, and contract values. The researchers offered a wide range within these 3 contract type, project type, and contract value categories. However, all of the project analyzed were sourced from capital facility type projects. This research presented more variety than the previous research, but it still was not as widespread as it needed to be. The author notes that research made use of non-random sampling methods owing to an unwillingness on the part of companies to share their schedule information. It should be noted that the primary focus of this study is not on the sourcing and substantiating of the metrics to be measured, but rather on the impact of the specific metrics on a diverse set of projects, both civil and building, and the identification of unique metrics that offer consistent implementation impact based on the project type. The research methodology used in this study included a literature review and analysis to establish the need for the study, previous methods used, metrics to be measured, and a need for future research. Schedule compilation and structural organization was then conducted, and then the researcher moved on to an identification of metrics to be measured and evaluated based on industry standards, questionnaires, and discussions with industry experts. An establishment of thresholds for these metrics was then used simply as a basis for evaluation on a pass-fail scale. The metrics measurements were conducted using existing validation software. An evaluation of the results was then conducted based on project type, project duration, and project density with respect to the number of activities within the schedule. Identification of critical metrics was then produced that are or are not unique to the specific characteristics listed above. An outline of the critical metrics based on the results of the evaluation was then published, and an outline of the contribution to the field of work was discussed. Finally, identification of research shortcomings and the need for future studies and evaluations is discussed. It should be noted that the selection of the 12 schedules analyzed in this research was completed with a high level of consideration given to the type of project selected, the project's duration, and the number of activities within the project schedule, referring again to the project density. With respect to project type, 3 categories were considered in this research: school buildings, horizontal and roadway projects, and projects located within a casino on the Las Vegas Strip. All of these projects are prevalent in Clark County, Nevada. In addition to this, the school projects considered had very similar layouts. With respect to project duration, the ranges varied from 200 calendar days at a minimum to 1,064 calendar days at a maximum. These ranges were divided into 2 categories: durations above 330 calendar days and durations below 330 calendar days. With respect to project density, the range varied from 19 total activities at a minimum to 747 total activities at a maximum. Although this range seems very large, there exist project schedules in excess of 20,000 activities. These types of schedules were not included in this analysis due to their complexity, as well as their inclination to have multiple various delays affecting the finish date of the project. Within this range, projects were divided into 2 categories: the number of activities ranging above 150 and number of activities ranging below 150. Separate from the 3 project characteristics previously outlined, each of the projects had a delay measurement conducted based on the variance between the original baseline schedule and the final as-built schedule of the project. This delay ranged from negative 27 calendar days, meaning that this project finished 27 calendar days ahead of what was projected in the baseline, to 66 total calendar days beyond the finish date projected in the baseline. It's important to note that the average delay incurred of the 12 schedules analyzed was 26 calendar days. This table outlines each of the projects through a unique identification system, each of the project types, 4 being of the school building type, 4 being of a horizontal or roadway type, and 4 being of a casino building type, the total project duration of the baseline schedule, the total project duration of the final as-built schedule, the project density, meaning the number of activities in the baseline schedule, and the time delay incurred, which was calculated by measuring the variance between the finish date of the as-built schedule and the finish date of the baseline schedule. The thresholds used for the 20 schedule metrics analyzed were established for measurement and evaluation based on several factors, those being a generalized review of previous research in the same field, recommendations from 15 industry experts, including project managers, estimators, schedulers, and project controls personnel, and a review of Clark County, Nevada and City of Las Vegas, Nevada, contractual scheduling requirements. Each of the 15 participants who were surveyed in this study were provided a scheduling metrics questionnaire that read, "Based on your professional experience as a construction industry expert, please rank/prioritize 5 schedule metrics that you believe to be most critical to the success of a project based on the following characteristics." These characteristics, as previously discussed, are project type, horizontal versus vertical, project length, and project density, again referring to the number of activities. Examples of these scheduling metrics were included in this questionnaire. It's important to note that although these thresholds have been established based on both literary and survey reviews, the focus of this study aims to define a relationship between the metrics themselves and the overall success of a project's schedule. It should be noted that the thresholds for the metrics can be adjusted based on the unique characteristics of a particular construction project. These thresholds simply act as a pass/fail scale and not a specific measurement of the variance between the threshold itself and the metric that it corresponds to. The following table represents each of the 20 scheduling metrics used to evaluate each of the schedules in this research. It should be noted that several of these metrics have a threshold of 0%. Some of these metrics include out-of-sequence logic, negative lags, finish-to-start lags, duplicate descriptions, duplicate relationships, and activities writing the data date. It should be noted that several metrics had to be eliminated due to lack of literature on the establishment of thresholds, as well as software restrictions. These metrics included activity identifications, activity codes and WBS codes, the ratio of detail activities to milestones, milestones with duration, project calendar metrics, and level of effort activity metrics. It should be noted that Primavera P6 software was used in the creation of all 12 of these schedules analyzed. As such, this software will not allow a user to create non-unique activity IDs, any milestones with a duration, or non-unique activity codes or WBS codes. In addition to this, there was a lack of literature on the establishment of thresholds for the ratio of detail activities to milestones, project calendar metrics, and level of effort activities. Presented is a table of results based on the evaluations and the outline of metrics used in the evaluation. The first 5 metrics include constraints, critical path, near critical path, out of sequence logic, and negative lags. In reference to constraints, of the 12 schedules evaluated, 0 schedules had more than 5% of activities with constraints. In general, constraints should only be used on the first and last activities in a schedule. The use of excess constraints can misconstrue the critical path of the project, thus misrepresenting time in which a project could be completed. Only the cogeneration project and restaurant project 1 had a constraint percentage above 1%. As a result of this, the impact of excessive constraints is inconclusive within the bounds of this study. In reference to the percentage of activities on the critical path, it should be noted that 4 schedules had a baseline critical path greater than 20%. A critical path consisting of more than 20% of activities is a good indication that the project is at risk of slippage with respect to time. The average delay of these 4 projects was 53 calendar days, well above the average of all the projects of 26 calendar days. In reference to project type, of the 4 projects that failed to meet this critical path percentage, 2 horizontal roadway project types and 2 casino building project types had a critical path percentage above this threshold. It should be noted that no school building project types failed this metric, rendering this critical path percentage evaluation inconclusive for this project type. In reference to project duration, of the 4 projects that failed to meet the critical path percentage, 3 projects had a duration beyond 330 calendar days. This is a good indication that this metric has a greater impact as the duration of the project increases. With respect to project density, of the 4 projects that failed to meet the critical path percentage, 3 projects had a project density below 150 total activities. The average delay incurred within these 3 projects was 51.3 calendar days, well above the average of 26 calendar days. Although this could be construed as an indication of increasing impact, the amount of critical path activities will always increase as the number of activities in a schedule decreases. As a result, this metric is inconclusive in relation to project density. With reference to near critical path percentages, of the 12 schedules evaluated, only 2 schedules had a baseline with a critical path metric higher than 40%. Although not as impactful as the critical path metric, this high percentage of near critical path activities is a good indication that many activities can become critical if there is any slippage or delay. Because the 2 projects evaluated here are of a different project type and project density, the results of this metric are inconclusive. In reference to out-of-sequence logic, of the 12 schedules evaluated, only 2 schedules had a baseline with a percentage of out-of-sequence activities beyond the threshold of 0%. Although this results in inconclusive metrics measurements, it should be noted that this practice should not be implemented in any project schedules. In reference to negative lags, 0 projects failed to meet this metric, rendering the impact of negative lags inconclusive within the bounds of this study. In reference to finish to start lags, of the 12 schedules evaluated, no projects failed to meet this metric threshold. As a result, this metric's impact is inconclusive. In reference to long lags, those greater than 10 days, of the 12 schedules evaluated, 4 projects had a baseline with a percentage of long lags above the threshold. Generally, long lags represent gaps within work and should be replaced with more detailed activities. The average delay of the 4 schedules that failed to meet this metric was 41.5 calendar days. In reference to project type, of the 4 projects that failed to meet the long lags threshold, 3 were of the casino/building project type. This indicates that long lags have an average impact on this specific project type. In reference to project duration of long lags, of the 4 projects that failed to meet this metric, 2 had durations beyond 330 calendar days, and 2 had durations below 330 calendar days. This is an indication that the impact of long lags is independent of the project duration. In reference to project density, of the 4 projects that failed to meet the long lags metric threshold, all 4 projects had a project density below 150 activities. This is a good indication that as project density decreases, the impact of long lags on the success of a project schedule increases. In reference to high float, of the 12 projects evaluated, 7 projects failed to meet the threshold set for high float. High float is generally an indication of missing logic ties within a schedule, and as a result, a schedule may misrepresent the feasibility of actually finishing on time. The average delay incurred of the 7 projects that failed to meet this metric was 40.6 calendar days. In reference to project type, of the 7 projects that failed this metric, 2 were of the school building type, 2 were of the horizontal roadway type, and 3 were of the casino building project type, thus rendering this metric inconclusive in reference to project type. In reference to project duration, of the 7 projects that failed to meet the high float metric threshold, 3 projects had a duration beyond 330 calendar days, and 4 projects had a duration below 330 calendar days. This is a good indication that the overall impact of this metric is independent of the project duration. Of the 7 projects that failed to meet this metric, 3 projects had a project density above 150 activities, and 4 projects had a project density below 150 activities. As a result of this is again an indication that the overall impact of this metric is independent of the project density as well. In reference to high duration, 8 projects failed to meet the threshold set for high duration. High duration activities should generally be broken down into more detailed activities in order to obtain more accurate progress tracking and more detailed logic within a schedule. The average delay incurred by these 8 schedules that failed to meet this metric was 22.5 calendar days. This is below the average delay incurred by all 12 of the schedules, thus rendering this metric inconclusive with respect to its effect on the schedules. In reference to duplicate descriptions, of the 12 projects evaluated, 5 of these projects failed to meet the threshold for duplicate descriptions. Of the 5 projects that failed to meet the threshold, the average delay incurred was 31.8 calendar days. However, because 3 of the 5 projects had delays of 12 calendar days or less, this metric can be considered inconclusive with respect to overall impact. With respect to the no predecessors metric, of the 12 projects evaluated, only 2 projects failed to meet the threshold for this metric, those being the cogeneration project and the fitness center project. An activity without a predecessor does not have a set start date unless it has a constraint as well. This may result in an activity whose start date is parallel to the data date of the project and shifts every time the data date is updated. It should be noted that these 2 projects incurred the greatest delays of the projects evaluated. However, due to the small number of projects that failed to meet this threshold, this metric can be viewed as inconclusive. This metric may need its threshold adjusted in order to obtain a more conclusive result. In reference to the no successors metric, 3 projects failed to meet this threshold. An activity without a successor is a good indication that the activity can be extended to infinity without any impact on the schedule. Thus, every activity should have a successor. Of the 3 projects that failed this metric, the average delay was 33.3 days. Because the project type and project duration categories varied within this metric, their impact was inconclusive. However, it should be noted that of the 3 projects that failed this metric, all 3 had a project density of less than 150 activities. As such, this is a good indication that as the project density decreases, the impact of the no successor metric increases. In reference to the open start metric, 4 projects failed to meet this threshold. An activity is considered to have an open start if it does not have a predecessor with a finish to start relationship. This may result in a skewed representation of the impact of the activity on the critical path. Of the 4 projects that failed to meet this metric, the average delay was 29.25 calendar days. This delay average is very close to the average overall delay of 26 calendar days, indicating that the impact of this metric within the bounds of this study is inconclusive. With respect to the open finish metric, 6 projects failed to meet the threshold set for this metric. An activity is considered to have an open finish if it does not have a successor with a finish to start relationship. Again, this may result in a skewed representation of the impact of the activity on the critical path. Of the 6 projects that failed to meet this metric, the average delay incurred was 39.1 calendar days, indicating a major impact to a project schedule. With respect to project type, one of these projects was a horizontal roadway project, and 3 were casino building project types. Again, no school building project types failed to meet this metric. As a result, it can be assumed that the open finish metric impact is independent of the project type. In reference to project duration, of the 6 schedules that failed to meet this metric, 2 projects had a duration greater than 330 calendar days, and 4 projects had a duration less than 330 calendar days. As a result of this, it can be assumed that as the project duration decreases, the impact of the open finish metric on the project schedule increases. With respect to project density, of the 6 schedules that failed to meet this metric, 5 of these projects had a project density of less than 150 activities. As a result, it can be assumed that as the project density decreases, the impact of the open finish metric on the project schedule increases. With respect to duplicate relationships, only 2 projects failed to meet the threshold set for this metric. Within the Primavera P6 software, priority is given to finish to start relationships, and as you duplicate a relationship, the software automatically establishes a finish to finish relationship on top of the existing relationship. It is difficult to incur an impact or a complexity based on this, and as a result, the impact of this metric is inconclusive. With respect to activities writing the data date, of the 12 schedules evaluated, only 3 projects failed to meet this threshold. Activities writing the data date is an indication that an activity's predecessor was manually actualized, and the activity's start date is now being pushed out every time the data date of the schedule is updated. This results in unintended start and finish dates for this activity and any other activity tied directly in sequence with this activity. Of the 3 projects that failed to meet the threshold set for this metric, the delays incurred were 58 calendar days, 28 calendar days, and 12 calendar days. As a result of this, it can be assumed that the impact of this metric is inconclusive. In reference to the finish to start logic metric, of the 12 schedules evaluated, 6 of these schedules failed to meet this threshold. Generally, schedules should maintain at least 80% of activities with finish to start logic ties. This aids in simplifying the logic in the schedule, making maintenance and progress updating simple, and this also aids in eliminating complexities within the schedule that may cause unintended or unforeseen errors. Of the 6 schedules that failed this metric, the average delay incurred was 45.6 calendar days, well above the average of 26 calendar days. In regards to project type, of the 6 projects that failed to meet this threshold, 2 were of the school building type, 2 were of the horizontal roadway type, and 2 were of the casino building type. This indicates the project type is independent of the impact of the finish to start logic metric. In reference to project duration, of the 6 projects that failed to meet this threshold for this metric, 4 had a duration less than 330 calendar days. As a result, it can be assumed that as the project duration decreases, the impact of the finish start logic metric increases. In reference to project density, of the 6 projects that failed to meet the threshold, half had a project density of less than 150 activities, and half had a project density greater than 150 activities. As a result, it can be assumed again that project density is independent of the impact of the finish to start metric. In reference to finish logic, no schedule failed to meet the threshold for this metric. Because of this, the impact of finish logic is inconclusive. In reference to start logic, 7 schedules failed to meet this threshold. Start logic should be minimized to avoid complexities within the schedule and unintended errors that parallel this complexity. Of the 7 schedules that failed to meet this threshold, the average delay was 43.1 calendar days, indicating that this metric has a major impact on the successful implementation of a project schedule. In reference to project type, of the 7 schedules that failed to meet this metric, 3 were of the school project type, 2 were of the horizontal roadway type, and 2 were of the casino building type. This is a good indication that project type is independent of the impact of start logic metrics. In reference to project duration, of the 7 schedules that failed to meet this metric, 4 projects had a duration less than 330 calendar days, and 3 projects had a duration of more than 330 calendar days. This is a good indication that project duration is also independent of the impact of start logic. In reference to project density, 4 projects had a project density greater than 150 calendar days, and 3 projects had a project density less than 150 activities. This is a good indication that project density is independent of the impact of the start logic metric as well. Finally, in reference to start to finish logic, of the 12 schedules that were evaluated, no schedules failed to meet this threshold. Start to finish logic is generally only used in extremely specific procurement cases and is generally frowned upon by the industry. Further, any start to finish logic can be replaced by a different logic tie with the same result and less complexity. Because no schedule failed to meet this threshold, the results of this metric evaluation are also inconclusive. The following table represents a summary of the results of the evaluation. It should be noted that several metrics proved to either be unimpactful or their impact was inconclusive. Additionally, it should be noted that the intent of the research was to determine not only which metrics have a general impact, but also how that impact varies based on 3 distinct schedule characteristics, those being project type, project duration, and the number of activities within a project schedule, referred to in this case as the project's density. The 7 metrics that proved to be impactful were percentage of critical path activities, percentage of long lags, percentage of activities without successors, percentage of activities with open finish logic, percentage of activities with finish to start logic, and percentage of activities with start to start logic. The only metric to be completely independent of all 3 schedule characteristics is the percentage of activities with start to start logic. The percentage of critical path activities has an increasing impact as duration increases. This is contrary to both open finish and finish to start logic metrics, in which the impact increases as the duration decreases. The percentage of long lags metric is the only metric that proved to be dependent on the project type, impacting the casino building project type more than any other. Long lags, activities without successors, and open finish logic metrics all proved to be dependent on the project density. The metric's impact increased as the number of activities in the schedule decreased. With regard to research significance, it should be noted that many previous studies have attempted to substantiate critical metrics that have a major impact on the successful implementation of a construction project's schedule. As a result of this, several studies have identified such metrics. However, several studies that exist are subjective in the metrics chosen, their corresponding thresholds, and the selection of evaluated projects. Further, the selection of evaluated projects lacks significant variety. This research aims to eliminate subjectivity, provide increased variety in analysis, and create a correlation between the 3 scheduling characteristics outlined and the corresponding metrics evaluated. Additionally, this research aims to further substantiate the impact of several metrics in a generic sense, as previously discussed. Although a variety of schedules were analyzed in this research, this topic could benefit from an analyzation of a larger database of schedules. Additionally, although variety was provided in this evaluation, more variety with respect to schedules can increase the substantialness of the research. Evaluation can also be conducted based on more than 3 schedule characteristics. In addition to this, an isolation of the metrics to eliminate concurrency of impacts and better understand the impact of each metric individually will benefit to the overall research in this field. Additionally, delay isolation, meaning separation of delays, may also provide a clearer picture of the overall impacts of each metric. This is a list of some of the references used in not only developing thresholds and metrics to be used in the study, but also in literary reviews to obtain the same goals. Finally, I'd like to extend gratitude to the industry professionals who provided insight and opinion into both the metrics and the metric thresholds used in this research. Additionally, I'd like to thank the entities that provided the schedules that were evaluated. It is well understood that this research could not be conducted without their significant contributions. Thank you, everybody, for listening.